Okay guys, so once again I am here and now we will continue with the next question. Oh yeah, so that is the question of chemistry only. So that's a single question. Let me do this question with you people. The question is, given below are the steps of extraction of copper from its ore. So certain steps will be given to you with the help of which you can extract copper from its ore. And next is you need to write the reactions involved for each step. Okay. The first step that has been written is roasting of copper sulphide. You know, right, what is roasting? So since it is copper 1 sulphide, so you will write down the formula copper plus S2 minus, so Cu2S, right? So copper 1 sulphide will now be treated with oxygen, and when copper sulphide is treated with oxygen, which is roasting, it will lead to the formation of copper oxide plus sulfur dioxide in the gaseous state. Okay, let's write the balanced chemical equation. 2 copper, 1 sulfur, 2 oxygens, 2 oxygens. So that's it. So this is the reaction for the first part. Done. Moving on to the reaction with the second part, which says that the reduction of copper 1 oxide. So see, what is copper 1 oxide? Again Cu plus O2 minus. So the copper 1 oxide is nothing but Cu2O. So copper 1 oxide will be reduced with copper 1 sulphide only, which is Cu2S, leading to the formation of copper plus sulfur dioxide. Let's balance 2 to 4 coppers. 4 coppers are there, 1 oxygen. No, something is wrong. So Cu2O plus 4, not 4 here. So let's first balance sulfur. Sulfur is 1, sulfur is 1. Oxygens are 2, so we need to balance oxygen 2. How many coppers are there? 4 plus 2, 6. So now you can make 6. Okay, so even this is done. And the third is, write the reaction for electrolytic refining. Also draw a neat and well labeled diagram for electrolytic refining of copper. This I'll do for you because for that I need to have the next board. Yeah. So we need to do the electrolytic refining of copper. Let me draw the apparatus. So in the apparatus you will be taking a container in which you have aqueous CuSO4. You will be making the impure copper electrode as the anode. You will make the pure copper electrode as the cathode. Okay, now you know that at anode oxidation occurs, and what happens during oxidation? Copper in the solid state will get converted into copper 2 plus in the aqueous state plus 2 electrons. So copper is getting converted into Cu2 plus 2 electrons. And what will happen? So at the cathode, you know that reduction takes place. So reduction means Cu2 plus from the solution will go and get attracted towards the negative electrode. So this will be positive, this will be negative, right? So this will go and get attracted towards the negative electron to form copper in the solid state. So once you will add the two, you will get the final equation for the electrolytic refining. So what is happening? Only the pure copper metal which is there in the electrode will get oxidized and get converted into Cu2 plus, and the remaining impurities will keep on falling and they'll get collected here at the bottom of anode, which will be known as anode mud. Okay, so this was the detailed answer for this particular question that I had discussed with you people. So I think this particular question is also clear. Now let me go out of the frame so that your bio teacher can enter and teach you the next question. I'll meet you soon. Bye-bye.
Okay friends, so now we will discuss the next question. Name the main excretory organ of the human body with its structural and functional unit. State decomposition of urine. We all know the main excretory organ of the human body. Okay, so the main excretory organ, the main excretory organ of human body, okay, of human body is urine. Sorry. The main excretory organ of human body is kidney. Right. We all know that all human beings have a pair of kidney, right? All human beings have a pair of kidney which are bean shaped, right? These kidney have, these kidney have tube like structures which are called as the ureters, and this ureter will enter into the urinary bladder, and from the urinary bladder the urethra will arise. Okay, it is this urinary bladder. So what happens basically, this is just for understanding, I'm telling you, these two kidneys will produce the urine. This urine will come through these tubes which are called the ureter. The urine will come, it will get stored temporarily in the urinary bladder, and when this urinary bladder is half full or 2/3 full, then you get the feeling of passage of urine, okay, and then when you urinate, this urine will come out to the urethra through your genitals and will come out of the body, right? So the main excretory organ of the human body is kidney. What are the other excretory organs of the body? Right, the other excretory organs, accessory excretory organs, you can say the liver, right? Apart from the liver, the skin, okay, the skin also gives out excretory products. When you sweat, along with the sweat, many toxic substances come out of the body. So the skin, the liver, but mainly it is the kidney. Then name the main excretory organ of the human body, which we have already named, with its structural and functional unit. The structural and functional unit of the kidney, the structural and functional, okay, the structural and functional unit of kidney is nephrons, okay. The structural and functional unit of kidney is nephrons, right. So what is the structural and functional unit of a kidney? The structural and functional unit of a kidney is nephron. Now these nephrons, okay, we will see what is the basic structure of a kidney. We will see, what happens, the incoming arterioles, okay. This is something, called the glomerulus, okay, and here we have what? The incoming, okay, and then what we see here is the proximal convoluted tubule, then we have the loop of Henle, okay, and then we have the distal convoluted tubule, okay, the loop of Henle, the distal convoluted tubule, and finally it goes into the collecting duct, right. I mean, the diagram is not so very beautiful, it's a horrible diagram, but we need to understand the concept. So what happens, this is the afferent arteriole, the artery which is coming, and the artery which is exiting is the efferent. E stands for exit. Understand this concept, it's very easy. So the lumen of this efferent or exit arteriole or artery is very less than lumen, and the lumen of this is wider. So when blood from a wider lumen artery will enter that of the narrow lumen, what is happening? The passage is decreasing, so the pressure will increase, and due to this pressure, which is called the glomerular filtration pressure, GFP, some blood will be filtering out over here. Along with this blood, the toxic substances like urea and other things will, and other salts will excrete out or will come out, will get filtered out, and this will go through the first part of the kidney called the proximal convoluted tubule, PCT. From here it will go to the loop of Henle, and from the loop of Henle it will go to the distal convoluted tubule DCT, where it will, after this it will be collected in the collecting duct. Okay, so the basic structure and functional unit of a kidney is the nephron. The nephron, further, each nephron consists of these parts. Okay, this part is called the glomerulus, this part is the proximal convoluted tubule, this part is the loop of Henle, this part is called the distal convoluted tubule, and this part is called as the collecting duct. Okay, and this part is what? The proximal convoluted tubule, which you already know. Got it, friends? Now the composition of urine is the third part of the question. Okay, the composition of urine. So in the composition of urine, we can say the composition of urine, we can say uric acid, okay, then salts, some of the salts, then toxic substances, okay, and excess water, right? Further, this is just a small detailed composition of urine. When we further talk at higher classes, we will see each one, each of these components in detail. So uric acid, the salts, toxic substances, and excess of water. Okay, so with this we have finished this question, and now we will move on to the next question. In a double displacement reaction between aqueous solution chemical reaction. So this is a chemistry question which will be dealt by the chemistry teacher involved.
Okay guys, so once again I am here with you people, and let's move on to the next question. So this next question is, in a double displacement reaction between the aqueous potassium iodide, we know potassium iodide is Ki aqueous, and its reaction is being done with aqueous lead nitrate. Lead is Pb, nitrate is NO3, twice aqueous. Okay, he is saying a yellow colored precipitate of lead iodide is formed. So do the cation and ion exchange, it will lead to the formation of, since Pb is in +2 oxidation state, it will form PbI2, which is yellow colored precipitate, and an aqueous solution of KNO3 will be obtained. So 1 Pb, 2 iodines, 2 potassium, 2 NO3, 2 NO3. Okay, fine. Now he is saying, while performing the activity, if lead nitrate is not available, name any other chemical substance that can be used in place of it. So when lead nitrate is not available, I just need to have lead in +2 oxidation state, which can be taken in any common compound, right? Like instead of lead iodide, you can take, instead of lead nitrate, you can take lead acetate, PbCH3COO twice. So once again, if you take PbCH3COO twice and do its reaction with Ki, it will lead to the formation of PbI2, again which is PPT, yellow in color, plus 2 CH3COO minus K plus in the aqueous state. So this will form potassium acetate. Okay. So write the chemical equation involved. So see, PbCH3COO twice plus 2 times Ki. So or Ki you can say to form PbI2 plus CH3CO minus K plus. So let's see balancing, 2 potassium, 2 iodine. Okay, 2 potassium, 2 iodine, 1 lead, 2 acetate, 2 acetate. That's it. Okay. That was an easy question, right? So this was our question number 22. Since now we are done with question number 22, I should be going out of the frame. But before I go out, let me just check the next question. Maybe it's a bumper offer that you are getting 2 chemistry questions simultaneously. Oh yeah, so we have got one another chemistry question. And it says that an experiment was carried out to determine the position of metals P, Q, R and S in the reactivity series. So since he is talking about reactivity series, let me first write K, Na, Ca, Mg, Al, Zn, Fe, Pb, H. I am so bad, I should have written it in small, like leaving small spaces. So once again, K, Na, Ca, Mg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag, Au. So anyhow the other you need to remember the series K, Na, Cmg, Al, Zn, Fe, Pb, H, Cu, Hg, Ag, Au. Okay. The results of displacement reaction are shown. So since we are carrying out the displacement reaction, I think one thing should be very much okay with you, that a highly reactive metal can displace a lower reactive metal. So potassium can displace all of these from their solutions, right? Sodium can displace calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, but not potassium. Similarly, zinc can displace all these but not above than these. This you know, right? Now these are the metals, solution metals P, Q, R and S, and these are the reactions with AgNO3, PbNO3 twice, FeSO4 and MgSO4. Now the question is, arrange the metals in the ascending order of their tendency to form positive ions. So ascending order of their tendency to form positive ion. Ascending means starting from lower and going to the top, right? So let's start. He is saying that when P is added to AgNO3, no results are there. When P is added to PbNO3 twice, no reaction is there. That means if Pb is here, so P will be like here. That is the reason why P could not be displacing. So why P couldn't displace lead? Because P must be any one of them. Now he is saying when it is lying, when it was added to FeSO4, then also no reaction. So genuinely when no reaction with lead, no reaction with Fe also. And when no reaction also with Mg. That's quite obvious, no? When no reaction with lead, no reaction with Fe, Zn, As, Mg, Ca, K, Na, K. Okay. So P will be lying somewhere here. Below lead, we will get P. So this is the best way to do this question rather than just assuming things. So just say P is somewhere here. Moving on to Q. When Q is added to AgNO3, you will find that silver is displaced. So Q must be lying here. Somewhere here, because that is the reason why it will displace silver. Okay. So here nothing. And here when it is added to FeSO4, no reaction. So it must be below FeSO4. Okay. And for MgSO4, again no reaction. So it must be below Mg also, since it is below. But now this is pretty much clear to me that wait. So since it is saying that P is also not reacting with AgNO3. So when P was added, no reaction with AgNO3 also. So it must be even below, right? P was not even reacting with AgNO3. So even below. How could I forget this? So see, once again I'll tell you, I'm saying when P is added to AgNO3, silver was not displaced, right? So P will be lower to silver. No reaction with PbNO3 twice, lower to Pb. No reaction with FeSO4, lower to Fe, lower to MgSO4, lower to Mg. Moving on to Q. Q can displace silver. So since Q can displace silver, it will come onto the top of silver. But Q gave no reaction with lead. So see, nothing is given with lead, no. So Q must be somewhere here. And genuinely when Q cannot react with lead, it cannot react with magnesium. See, no reaction with iron, no reaction with magnesium. Clear? Now moving on to the lead, when R is added, silver is displaced. So when silver is displaced, so it must be somewhere here, above silver, right? Even lead is displaced. So not here, So R will be above lead because lead is displaced. Now he is saying even iron is displaced. So it will be even better than iron. So R will be somewhere here. Okay, but no reaction with MgSO4, so lower to MgSO4. Okay, now moving on to S. Silver is displaced. Okay, so somewhere here. Lead is displaced, so somewhere here. And then he is saying no reaction with Fe, so it must be somewhere between this and this because it could not displace iron. So since it could not displace iron, so S must be somewhere here. Okay, now finally if I am asking you to tell me the range, like how these are arranged, you can easily see R, then S, then Q and then P. Fine. So which have the least tendency to form cation? You know, right, potassium has maximum tendency to form cation. So R has maximum tendency to form cation. Since you have to write the ascending order, write PQ SR. That's it. So this is how this particular question can be done. This is really a good question and you should be expecting a similar kind of question to be asked in your CBSE board exams. Make sure please you do the question very nicely, you do the concept very nicely. The way I have explained is good enough, so you should be understanding it and you should also digest it. I hope this was the last chemistry question, so I won't be meeting you once again in the paper. So for your exam, all the very best. Do the paper very nicely, very patiently, very consciously, and please do not bite your nails while solving the paper. Take care. Bye-bye.
Okay friends, now we will discuss the next question. While observing the temporary leaf peel, how would you differentiate guard cells from the rest of the epithelial cells? Okay. So for this answer, for this particular question, you have to understand what are guard cells, where are they found, where are the epithelial cells, where are they found. Now the first part of the question says while observing the temporary leaf peel. That means definitely the guard cells will be somewhere in the leaf and even the epithelial cells are somewhere in the leaf. Yes, you are absolutely right when you have correlated this way, and this is how you should first correlate and then form your answer. Okay, so the guard cells are cells surrounding the stomata. Okay, these are the cells surrounding the stomata. That is the stomal opening or the pore. That is stomal opening, okay, or pore. Okay. Now these guard cells have a distinct shape. These guard cells have a distinct shape. That is they are what? They are kidney shaped, kidney or bean shaped, that is kidney or bean shaped in dicots. Okay, you know what are dicots? Those seeds which have two cotyledons are called as dicots, and these are dumbbell shaped. Okay, dumbbell, you know what is a dumbbell? Ask a gym freak and he will tell you, he'll tell you what is a dumbbell. Dumbbell shaped in monocots. Okay, what is a kidney or bean shaped? Something like this, right? And what is a dumbbell shaped? Something like this. Okay. So these are kidney or bean shaped, right? These are kidney or bean shaped in dicots, and these are dumbbell shaped in what? In the monocots, that is these guard cells. Also the guard cells, okay, I'll write the differentiating feature here only from the rest of the epithelial cells. The other epithelial or the epidermal cells, other epithelial or epidermal cells are irregular in shape. Okay, irregular in shape. So let us understand this. Let us understand this with a very simple diagram. Say I've drawn the structure of a leaf. This is the midrib of the leaf, which we all know. This is the lateral vein, okay, and this, the upper and the lower surface, form the dorsoventral surface, right? We know that the stomata or the opening are more on the lower surface than on the upper surface of the leaf, right? Now, so let us think these are the stomatal opening, okay? These are the stomatal opening in the leaves, okay? These are the stomatal openings which are more on the lower side than on the upper side. Surrounding these, when you consider a section of the leaf like this, there will be many cells. There will be many cells. All these are epidermal cells. Those epidermal cells which will be surrounding the stomata are called as the guard cells, while the other epidermal cells are simply the epidermal or the epithelial cells, right? So those which are surrounding the stomatal opening or pore or the stomata, they are called the guard cells. These guard cells have a distinct shape. They are kidney or bean shaped in dicots, and they are dumbbell shaped in the monocots. Okay. For example, I'll draw this diagram again. For example, let us consider, okay. So this is the stomatal opening of the pore, the stomata. Surrounding the stomata are the two guard cells over here, okay, which are kidney shaped. That means this is a dicot leaf, and these are the epidermal cells. These are the other epidermal cells. Okay. This is what? This is the guard cell. This is the stomatal opening or the pore, the stoma or opening. Okay, got it? Now we will see the other difference. Now we are going to consider the other difference. Let this diagram be here only. The other difference is guard cells. The guard cells have a number of chloroplasts. Okay, guard cells have a number of chloroplasts. However, other epidermal cells, other epidermal, in other words, epithelial cells, do not have chloroplast, okay? Do not have chloroplast, right? So we will see now here, these are the guard cells. These will be chloroplast present in their body, okay, the chloroplast. Guard cells have a number of chloroplasts, yes. However, the other epidermal cells do not have chloroplasts, so that's what I have explained you, and this is done. We have done the differences that yes, the guard cells have a distinct shape, the epidermal cells do not have a distinct shape. The guard cells have chloroplast, the other epidermal cells do not have chloroplast, and the guard cells have thickening of their walls, which the other epidermal cells do not have. So friends, we have completed this question, and now we will move on to the next question. that germinating seeds are used for experimentally showing the release of carbon dioxide during the process of respiration. Why? A very simple question. In fact, if you spend some time on this question, this itself will answer that why these seeds are used experimentally for showing the release of CO2. Germinating seeds have a high, germinating seeds have a high rate of respiration. Okay, before respiration I'll write germinating seeds have a high rate of growth, and since growth rate is high, so their respiration rate is also high. Okay, so their respiration rate is also high. Okay, that is, they will release carbon dioxide in large amounts. That is, they will release carbon dioxide in large amounts. Okay, so germinating seeds have a high rate of growth, and since growth rate is high, so the respiration rate is also high. That is, they will release carbon dioxide in large amounts, and that is why we are using these germinating seeds for experimentally showing the release of CO2, because since the growth rate is high, the respiration rate will be also high, and respiration rate means what? CO2 will be given out, oxygen will be taken in, and hence we want to see the release of CO2, and that is why these germinating seeds are used. Also, these seeds can be commonly obtained using pulses, chana, moong, masoor and all that, etc. Right, friends? So this was the last question. I hope everything is clear in biology. With this we have completed the biology questions. Any doubt, you can always come back to me, but revise this, see these questions again, the logics behind it, and I hope this will be very simple. Okay, see you the next time. The next question will be continued by the other faculty, which is of a different subject. The time we meet again, a very goodbye from Dr. Ashmi. Thank you.
Now the next question is, a heater joined in parallel with a 60-watt bulb is connected to the mains. If the 60-watt bulb is replaced by a 100-watt bulb, will the rate of heat produced by the heater remain the same in comparison to the first case or not? We have to tell them whether the heat remain will be same or not. A heater joined in parallel with a 60-watt bulb. Firstly, we have been given with power. Secondly, it is connected to the main. If the 60-watt bulb is replaced by a 100-watt bulb, and remember, since it is a thinking based question, a 2 marks question, so we just have to apply our thinking and our knowledge about this, knowledge about the formula, and we not have to lengthen the question, we just have to be on the point and tell the answer correctly. So now, if it is being connected in parallel, then what do you think? What will be the resistance if two resistors are connected in parallel position? Then we know that if it is being connected in parallel position, then R, that means resistance, is inversely proportional to power. We know the formula, and through that we have been declared that R is proportional to P, inversely proportional. Since R is inversely proportional to P,
then we can say that net resistance, we have been replacing 60 watt with 100 watt. That means power is increasing, and since power is increasing, resultant resistance will be decreasing. So net resistance will decrease. Okay, we have said that resistance will decrease. Now we have to tell them, will the rate of heat produced, heat, that means energy, H equals to V square by T. Okay, by the heater remain in the comparison to the first case. So we just have to think any formula that will be related to this. We have said that resistance is being decreasing. So our formula is H equals to V square T by R. So what we have to tell, we have to compare between them. Net R has been decreased. So what do we mean by heat? Heat will increase. If the net resistance is decreasing, so our heat, that means energy, heat will be increasing. It is simply a formula based thinking skill question. If you know the formula, if you know the relation between them, you can easily tell them whether the resistance or whether the power is been increasing or decreasing. So this was the question that we have done with, and we have said that if the resistance will decrease, our heat generated in the case will increase. So we are done with the question. Now we'll do the next question. This has been given that using 1 unit of electricity, 1 kilowatt hour, how long can you listen to a transistor radio of power 1 watt? Since it is a 2 marks question and it is a thinking based question, we just have to apply our thinking, and we know the formula that energy equals to power into time. Power into time. And we have been given energy. Energy is 1 kilowatt hour. We have been given power and we have to find the time. This is a simple relation that we have been given, and we have to find time here. So now we are going to put, since we know that we are going to put the standard units, that means we are going to convert this into a kilowatt hour into watt. 1000 into 3600 seconds. Okay, so now our time will be energy into, energy is what? Energy is power is 1 into T. So T is 3.6 into 10 is power 6 second. It's easily we can say that since power is 1, so we have put the value of power here 1, and it is, since the value of energy is 1 kilowatt hour and we have converted it into watt. So we have been given time here. So we have found out the time which has been asked in the question, and now we are done with this part. Okay, so this was the question. Energy has been given, power has been given, and time has to be found. We have applied the formula energy equals to power into time, and we have found the time. Okay.